Now we're going to actually switch roles and talk now about the partial correlation and how we can use that type of correlation coefficient in our research. So it's important to know that the partial correlation is a measure of the strength and the direction of a linear relationship between two continuous variables while controlling for the effect of one or more variables. And typically it's continuous, but you can have it be nominal, interval, or ratio as a level of measurement depending on your research question. So in this situation, although we don't have to make a distinction between independent and dependent variables, those two variables are often considered in this type of research. So you would have one dependent variable and then one independent variable, and these are both measured on a continuous scale, meaning that they're measured either as interval or ratio data. Some examples of that could include your revision time measured in hours, intelligence by IQ score, exam performance measured with a score of 0 to 100, weight measured in pounds, temperature measured in Fahrenheit or Celsius, sales measured in US dollars, etc. So in a partial correlation, you actually remove the influence of the third variable from the relationship. And your covariate can be nominal, interval, or ratio scale measure of data if you check out a little bit more on how Andy Fields does his analysis of these kind of situations. So let's talk about some times when you could use a partial correlation. You might want to know the relationship between test scores and GPA scores. After controlling for the hours spent studying, this would be a great example for someone studying in agricultural education. Another way you could look at this is maybe the relationship between height and weight while you're controlling for the effect of gender on the correlation, because we know that our weight and gender, we would have different bone structures, different body type. So that could be a factor that we need to look at when looking at relationships between height and weight. But I'm also going to give you a situation where you could use a partial correlation to understand whether there's a linear relationship between ice cream sales and price while controlling for your temperature and what's the daily temperature outside. And so the continuous dependent variable would be ice cream sales, and that is measured in US dollars. Your continuous independent variable would be price, measured in US dollars. And then your single control variable would be the daily temperature, and you can have that measured in Fahrenheit or in Celsius. You may believe that there's a relationship between ice cream sales and price. So sales go down as price goes up, but you might think that the relationship is affected by the daily temperature. And so if you think customers might be more willing to buy ice cream when it's a really nice hot day, so they wouldn't really care about the price. I need you to understand that when we do sources a bias also for partial correlations. So we need a linear relationship between all three variables. And that is all possible pairs of variables must show a linear relationship. And you have to accomplish this visually by inspecting your scatter plots. There should be no significant outliers. Outliers are just simply single data points within your data that do not follow the usual pattern. And partial correlations are very sensitive to outliers because they can have a very large effect on the line of best fit and the correlation coefficient, which can lead to an incorrect conclusion regarding your data. Therefore, it is best that there are no outliers or that you've kept them at a minimum. Your variables also need to be approximately normally distributed. So in order to assess the statistical significance of the partial correlation, you need to have bivariate normality for each pair of the variables, but this assumption is difficult to assess. So the easiest method to do is to run the Shapiro-Wilk test of normality, and you'll just interpret it like you do the Kolmogorov-Smirnov test of normality. So when you run a partial correlation, it is different than the point biserial, because you actually have to do two different situations. First, you just need to run the correlation between your two variables that are the independent and the dependent. And you need to look at that correlation and what relationship exists between those variables. Then you have to rerun the correlation while you're actually controlling for a covariate. And that way you can really see what influence that covariate has on those variables and the relationship between those variables. And so to demonstrate this, we are going to refer to task 7 in the chapter, and it asks you to repeat the analysis from task 6, which we just did in this lecture, taking an account of animal liking while computing the correlation between life satisfaction and the animal to which the person was married. So the biggest thing we're going to do is just make sure we control for the effect of animal liking. For our partial correlation, I am now going to go to Analyze, Correlate, Partial. We need to make sure that type of animal is one of our variables. Life satisfaction is another variable. Then the variable that we're actually controlling for is love of animals, so we bring that down to this box. We want to display the actual significance level, and we're doing a two-tailed test of significance. So we're going to hit OK. We are not going to bootstrap our data. So we are going to look at the table right here on the screen, and we notice that the partial correlation between wife and life satisfaction is 0.701, and we need to be able to compare that to the correlation of when we're looking at just wife and satisfaction. And if you remember that situation, we know that it was only a correlation of 0.630. So the partial correlation is actually greater than the correlation when the effect of animal liking is not controlled for. So the correlation has become more statistically significant. The p-value decreased from 0.003 to now 0.001. And we know with our variance, we can now calculate that by just doing the 0.701 and squaring it, and then we'll get 0.491, and we will times that by 100, and we get a variance of 49.1%. So in terms of variance, we know that the type of animal, wife, now shares 49.1% of the variance in life satisfaction compared to 39.7% when animal liking was not controlled for. So by running this analysis, it has shown us that the type of animal wife alone explains a large portion of the variation in life satisfaction, and that the relationship between wife and life satisfaction is not due to just animal liking. So let's take a look at how this is with writing it in APA style. Now I'm going to talk you through how to report all of the data we just saw in our output is a APA style write-up. So we need to look at the correlation coefficient, which is our little p for partial correlation, your significance level, and your variance. Now we did not use the bootstrapping as a robust method for handling our data because we didn't have any outliers. I didn't see any need for it given the situation with this data. So I don't report the bootstrapped confidence interval. You definitely can do it, and in that situation, you have one other component to add into the text. But what we have to focus on is making sure that we report our partial correlation as RP. It has to be italicized, and then the correlation coefficient goes to 2 decimal places, so it would be 0.70. We do not put a 0 in front of it because you can have a correlation above 1. And it's important to know that it's okay to make sure you round. So in a situation like this, we have 0.701. So we can just say 0.70. But in other times, you might need to round it. Our p-value is the next thing we got to think about. So in this situation, we can give the exact p-value, and it is p equals 0.001. You don't need a 0 before the decimal point, and the p is also italicized. And then with our r squared, that is our coefficient of determination. It tells us our variability or our variance. So we do r squared of 0.491. We can go to 3 decimal places, and we do not need a 0 in front of that. And just remember, when you write it, you would have to explain that it's actually 49.1% of the variance in life satisfaction is shared with the type of animal wife. If you have any questions or comments about the partial correlations, the point by zero correlation, or information that we covered about correlations in general, please reach out to me through Canvas inbox. Have a great day.